Today we are going to look at another example on specific heat and calorimetry. And this one says, suppose two substances having masses M1 and M2 in grams, specific heat C1 and C2, and temperature θ1 and θ2, where θ1 is bigger than θ2, are mixed together such that temperature of the mixture is at equilibrium. And of course, we have the expression for heat loss equals to heat gain. So here we have M1C1 θ1 minus θ mixture equals to M2C2 θ mixture minus θ2. So the instruction now is solve for θ mix, that is, make θ mix the subject, and what would be the new expression. Okay, so for us to be able to solve this, we must first expand the bracket. So the two terms outside, M1 and M2, would be used to multiply with θ1 and also with θ mix. And then the two terms outside here, M2 and C2, would be used to multiply with θ mix and also θ2. So let's move to the next step. This is the equation. When we clear brackets, we get the expression M1 C1 times θ1 will give us M1 C1 θ2 minus M1 C1 times θ mix will give us M1 C1 θ mixture. We are done with that one. Equals to, the same thing is applied here, M1 C1 times θ mix here will give us M2 C2 θ mix minus, you now look at this, M2 C2 times minus θ2 will now give us M2 C2 times θ2. Okay, so now that we have been able to clear the bracket, since we are trying to solve for θ mix, all we need to do is to collect like terms. So I had to write it there so you see clearly the next step to do. Like terms means that all those ones that come with θ mix, we are going to bring them to one side, and the other expressions that do not have θ mixture would be kept on the other side. And of course, we can see here we have minus M1 C1 θ mix and M2 C2 θ mix. So we are going to put both of them, those ones that are on one side, those ones that are with θ mix, we are going to bring them to one side, and then the other ones to the other side. And when we do that, we have to take note of the signs. If I'm moving a minus sign, like minus M1 C1 θ mix to the right hand side, the sign will change because this is negative. It will change to positive. If I'm moving a positive value to the left hand side, the sign will change to negative and all of that. So let's look at the next step. If we collect like terms, then we will have M1 C1 θ1 plus M2 C2 θ2 equals to M1 C1 θ mix plus M2 C2 θ mix. How did we get this? We had minus M1 C1 θ mix. We now move it to the right hand side. So the negative sign here changed to a positive sign. Already this one was plus, so we didn't do anything. And we already had M1 C1 θ1 here by the left hand side. Look at my cursor. by the left hand side. So we didn't touch this, but rather we brought minus m2 c2 theta 2 to the left hand side, and we observed the sign. So the minus sign was changed to a positive sign. Okay, so since we are making theta the subject, I'm not comfortable keeping my expression this way. So I'm going to rearrange it. And when I rearrange it, I'm not going to touch anything. I just want to bring the terms by my right hand to the left, and then the ones by my left hand to the right hand. So this is it. I didn't change anything. It's still the same expression, but I just wanted to put it well. Now, what's going to be the next thing to be done? I'm going to factorize the common term. If you look at the left hand side, you see that theta mix is here, and then theta mix is also here. So we are going to factorize it because it's common to m1 c1 and m2 c2. So when we do that, since we are looking for ways to solve for theta mix, when we factorize that, then we will have theta mix into m1 c1 plus m2 c2 equals to m1 c1 theta 1 plus m2 c2 theta 2. What did we do? If you multiply the theta mix by m1 c1, you get the previous expression here. And if you multiply theta mix by m2 c2, you will get the previous expression that is up here, m2 c2 theta 2. So now at this point, what are we going to do next? Divide through by the coefficient of theta mix. The bracket, the term in the bracket here is the coefficient of theta mix. Of course, if I'm to divide both sides by that coefficient, which is m1 c1 plus m2 c2, then I will have a new expression formed, which is m1 c1 theta 1 plus m2 c2 theta 2 all over that coefficient m1 c1 plus m2 c2. Okay, so we have come to the end of this problem. Now, in a situation where you have common terms, like the specific heat capacity are equal to both sides, then the expression reduces to theta mix equals to m1 theta 1 plus m2 theta 2 over m1 plus m2. That is when the expression here has a common specific heat capacity. Okay, but if the masses are the same expression, like if m1 is equal to m2, then the expression will, in short, m would be eliminated from this expression. Yes. Looking at the first one, if the specific heat capacity is the same, then in that expression, the specific heat capacity would be cancelled out and others would be left. The same thing happens to masses. If you have the same mass m1 and m2, then it will cancel out and that expression would be left with theta mix equals to theta 1 c1 plus theta 2 c2 all over c1 plus c2. Now, if the masses are the same, like m1 is equal to m2 and c1 is equal to c2, then you will have the temperature of the mixture to be theta mix equals to theta 1 plus theta 2 all over 2. Please thank you very much for your time. Do us a favor by clicking on the subscribe button. God bless you.